So we're ready to jump into the sim itself. So let's just actually continue from where we were building up our source. I will put a little null here to say that this is the source. That's where we're at there. And I guess we might as well update this to no longer say source. This is now just the full-blown sim. I'll make it purple too. So the .NET. The .NET, as you know, is where we're going to put all of our sparse stuff. So type tab, type sparse, pyrosolver. What else do we need? We need so typing sparse again, smoke object, sparse. So you'll notice, in general, that we've been using these smoke object sparse and the smoke solver sparse. There is no pyro object sparse. It's just, they just both use the smoke objects. So just so you know. In fact, the pyro solver has the smoke solver inside of it. It just has some other things as well. So far so good. And let's do a volume source. Volume source. Source. So what should the source be? Well, the first context geometry, because that's what's coming into here. Now, it's not sourcing anything yet. There's nothing here. If you're tempted to, say, do source fuel, this is what it used to be in the old Pyro. A lot of this stuff is still in terms of the old legacy Pyro. Back then, we used fuel. Fuel is not used at all anymore with sparse, and thank God for that. It used to be a lot more complicated. Back in the day, you had to source fuel and temperature, and you don't have to do this, but let me just show you. So fuel would then be ignited by the temperature, and then a certain amount would be burned, and a certain amount would be left over, and fuel itself could be advected, and there's a certain speed that it was advected, and not the worst thing in the world, and it was kind of the most popular model at the time, but I do agree that with the changes that they've made, where we now just add the fire and temperature manually in. It's just, you have more artistic control. So I deleted all that stuff. This can just go back to, just being whatever. Let's just do it ourselves. So first thing we want to add is temperature. And this is one of the most fundamental things of a pyro sim, is the heat. So let's see it. Now, if I press play, we won't see anything happen. Reason why is that normally the sparse solver will kind of expand to include the stuff that we've added into it, and as it advects, it gets bigger. The thing is, the pyro solver doesn't do that by default for temperature. It only does that where there's density and flame, because those are the two things that you actually see. Density being the smoke and flame, of course, being the flame. So temporarily, I'm going to put temperature here. We'll get rid of it though. Temperature. Press play. Now we can see something is happening. Still don't see it because there's no visualizer on for it. So we can go down to temperature. There you are. And I guess I shouldn't have done the camera on the x-axis, but I'm not going to change it now. But there it is. We can see it happening now. This is a cross-section, essentially, of it. In fact, I'll go to this side. It's brighter on this side. So let's go to the temperature tab, change it to black body radiation, or just says black body there. And I'm going to go to smooth shaded here. Good. So this is the temperature in our system. It's working. So there's a few things to talk about here. First off, temperature is what we're going to use to shade it later on when it is fire. Because remember, we're going to have a field that says that there is fire here. That's going to be our flame field, and that's going to be based off of our burn. But again, we'll talk about that later. More importantly right now is that temperature is going to be used both as a thing to create buoyancy, meaning heat rises, and later it's going to be used for shading the color of the flame. So the color is this black body business here. Black body radiation is the idea that mass gives off light the hotter that it gets. You're familiar with this. You've seen a lava flow where you've got like black rock, but it's red hot and it's molten. You've seen explosions in movies. And you've seen just hot metal, probably like a blacksmith hammering on something, where a bar of iron might just be black, but then it turns red as it gets hotter, and then it's yellow, and then it's white hot in the hottest parts. So all kinds of things exhibit this, and that idea is called black body. But going back to the other thing I said is buoyancy. That's what we're seeing happening right now. Now, we never added velocity into the system. We only added temperature. And yet, there is velocity. We can even turn on a visualizer for velocity, and there you go. It's a regular velocity field. There is velocity. So buoyancy is creating velocity based on temperature. So the idea is that heat rises. And so as it rises, other things are kind of getting out of the way and swirling around because it is essentially a liquid sim after all. And make no mistake, these smoke sims are liquid sims. They use the same dynamics as liquids do. Even when we talk about Flip in the Flip series, underneath the particle aspect is that it's happening inside of a kind of a smoke sim environment. So there it goes. We have buoyancy, and we can control the buoyancy on the pyrosolver. So as we go through the solver, we'll talk about all kinds of things, and first on the list is temperature and what it means for buoyancy. Buoyancy is based off of the idea that less dense things rise up and more dense things go down. Cold air is more dense. Hot air is less dense because it has expanded somewhat. Gravity is what causes that to happen. So paradoxically, we have a situation where without gravity, there's no buoyancy. Isn't that weird? Gravity, we're used to just pulling things down. But apparently gravity is needed to make things go up in this case. That's kind of funny. So you can control how strong your buoyancy is here. You can literally just also say, I just want more buoyancy and whatever. So there you go. You can see it's going much faster now. You can even just change it on the reference temperature. Ambient meaning we're sourcing a temperature volume in, and it was based off of point values that we created here. Those point values were from like 0.2 to 1, more or less. So these volumes that we created are also basically voxel values that are going from about 0.2 to 1. And so when we're in here, our simulation field is filled with values that might go beyond 1 even, or below 0.2 certainly, but they correspond to this. When the temperature is 0, it is 300 degrees Kelvin. And when the temperature is 1, it is apparently 600 degrees Kelvin. So the hotter that the upper range is, the hotter that the 1 is, the faster it's going to rise as well. So this also will make it rise much faster. Also, for the record, the reason why it looks like it's spazzing out sometimes is because this slicing thing is trying to stay in the center, which is not very helpful, but that's what it does. So you're just getting a different cross-section sometimes as the dimensions change a little bit. But in any case, 6,000 degrees Kelvin, and again, Kelvin's just another unit of measurement like Celsius or Fahrenheit. Kelvin is like a standard scientific one. The higher it is, the hotter it is, which means it, again, rises faster. I'm going to keep it at the normal amount for now. So to round this out, what else we have? We've got temperature diffusion. Diffusion is like when we've talked about density diffusion before, where it will blur things. In fact, it blurred it quite quickly. Or maybe we should just have it do much less. So it's blurring it, and it's just not going to be as sharp. I mean, that's what happens with heat. It diffuses outwards. It radiates heat the way you stand near a radiator, and it diffuses out. I would say typically we don't want too much diffusion because we were trying to get as much detail in our sim as possible. But that is what it is. I'm going to keep it at 0. Cooling rate also does what you would imagine. It is subtracting away from the sim a certain amount of temperature. So the higher it goes, the less, it starts to disappear. It's disappearing because of the cooling rate. If I had a very high cooling rate, it doesn't go anywhere. It's just subtracting so much heat from it. It's adding new heat in, but it's also subtracting a lot. So again, that you might actually want to play with, but I'm not going to in this case. So the last thing we need to talk about before we move on is the fact that look at the dimensions on the first frame of our entire sim, and then look where the heat is on the first frame. It's the same exact thing. We need to turn on, as you've seen in previous lessons, enlarge fields contain sources. So we just want to make sure that if we're adding a source that is beyond the bounds of our sim, that the sim itself resizes itself to accommodate it. So there you go. Now I'm using a slice to look at this temperature, but you can actually use smoke instead. So it looks like a regular smoke sim. I kind of prefer, again, the plane approach, but honestly, you're probably not even really going to be looking at this that much. But we'll keep it as the plane for now. Sweet.